Abu Michael, aka Abu Miki, your online tutor. I just want to look at another topic, logarithm. I'll be taking them one after the other. Logarithm is also another topic that may have given some people one issue or the other. I trust that this class will be able to resolve it. To start with, logarithm is the number of times. The logarithm of a number is actually the number of times 10 is raised to give a number. What I'm saying is this. Log 100, for example, log 10 is equal to 1. Log 100 is equal to 2. And log 1000 is equal to 3. So you see, if you look at it very well, you will observe that 10 raised to power 1 is 10. 10 raised to power 2 is 100. And 10 raised to power 3 is 1000. So we can conclude that logarithm and indices, they have a kind of relationship. If log 100 is 2, then 10 raised to power 2 is equal to 100. So if you look at it very well, we can conclude that there's a kind of relationship between logarithm and indices. Very, very simple. Do not mind that that's my daughter's voice. At this time of the night, she's supposed to be sleeping. Guys, let's just continue. Let's continue. Alright? Let's continue. Alright. Okay, sorry about this. This, my daughter is actually disturbing me. Well, we can actually generalize what I've written here. But before I do the generalization, I would like to quickly emphasize something. Now, when I wrote log 10, I didn't write the base to which we have that logarithm. Well, by the definition, log 10 can actually be written as log 10 base 10. And log 100 can actually be written as log 100 base 10. So it means we have two different nomenclatures of writing logarithm to the base of 10. It's either we write a number with the logarithm, or write a number with the base, or we write a number without the base. What I'm saying is this: log 10 can also be written as log 10 base 10. So these are the two different nomenclatures for logarithm. Log 100 can be written as log 100 base 10. Now, what now happens if it is to another base? Well, if the logarithm is to another base, then we'll have to write the base there, e.g. log 25 base 5. So it will be clear that for this logarithm, the 25 we are considering is to the base of 5. I will just itemize some rules, then we'll use this rule to kick off very, very quickly. My first rule, or our first rule rather, will be this one. Log a base a is 1. Okay? Then we have another one, log a raised to power x base a will give us x eventually. Now, in case you are wondering how this is, when you see an expression like what we have now, log a raised to power x base a, this whole expression can be rewritten as this. I will take the x, which is the power, take it to my left hand side and write it as x log a base a. Now, if you remember, we just said that log a base a is 1. So if I replace that log a base a with 1, I finally will get x. So that is how this rule actually came about. So we have addressed two rules. Then thirdly, it is important to know that logarithm and indices have a direct relationship. And the relationship is this. We can, if we have, say, log y base a is equal to x, for example, this whole thing can be written as a raised to power x is equal to y. So that is it. Just three rules that I want to address in logarithm. So once you perfect these three rules, you can simplify logarithmic expressions very, very easily. From expressions, we can now start taking more complex rules. Then we can start combining those principles to, solve logarithmic questions logically. I'll start with my first example, guys. I hope you are following me. Please, if I'm too fast, you can make comments. You can comment in the section so that I can pipe down a little. I just want to cover as much as we can because I know you guys have exams. Sometimes these things give trouble, so I just want us to finish it on time. Shall we? Now see. Now let's say you were asked to simplify log 8 base 2. Now we have two ways of making this happen. I can use the first two logarithmic laws I wrote in my page, or I can change it to indices then solve. Now guys, watch. If you look at this very well, you all know that 8 can be expressed in terms of 2 as 2 raised to power 3 then base 2. Now this whole thing is now looking like log a raised to power x base a, and we said log a raised to power x base a will give us x. So if I have log 2 raised to power 3 base 2, it means my answer is going to be 3. And once you see this, you can just write equals to 3 and you'll be correct. Now if you don't want to write the answer directly, you may write, take the 3 to the left like we did for the rule, then write log 2 base 2. You can now write 3 times 1 then is equal to 3. But I think this is kind of long, but if you so wish to go about it like this, then so be it. I believe this is simple enough. Now the other way we can address this is to change that logarithmic expression to an indicial equation. How? We can say let log 8 base 2, let it be equal to x. Now this rule is now looking like log y base a is equal to x, where we concluded that it will be written as a raised to power x is equal to y. Now if I compare this question with the rule, then it means that my a is like my 2, my y is like my 8, and my x is like the x that is written there. So for the question I've highlighted, if I want to write it in indicial form, it can be written as 2 raised to power x is equal to 8. Now once you've written 2 raised to power x is equal to 8, then we can now solve it indicially. 2 raised to power x is equal to 2 raised to power 3. Since they have the same base, then x is equal to 3. So you see, it doesn't matter how the question comes, you can always solve to get an answer. Now guys, I would like you to try this yourself. Tell me what the answer will be. If you have, say, log 49 base 7, what will the answer be? I'll give you like 10 seconds to quickly figure that out. I think 10 is too much. I'll give you 5 seconds to figure that out. If you got 2 as your final answer, I would say you have done a very great job. I believe you must have done something like log 7 squared base 7. And since you now have that kind of log a raised to power x base a thing, you concluded that your final answer is 2, which is very, very correct. Now there are times where the number may not be easily expressed in the base form. What I'm trying to say is this. Let's say, for example, that this question, or we have a question that goes thus: log 2 base 8. It's actually very difficult to express 2 in terms of 8. But I can express 8 in terms of 2, but I can't express 2 in terms of 8. So I will not be able to use log the first law we itemized in this page, and the second law we itemized also. It will make perfect sense if we can change all of these to indices. So if I say let all of this, let log 2 base 8 be equal to x, then we can end up having 8 raised to the power x is equal to 2. I believe you know how I got that equation. Okay, so I will write that, guys. If I write 8 raised to the power x is equal to 2, then 2 raised to the power 3x is equal to 2. Don't forget there's an invisible one here, so 3x is equal to 1, then x is 1 divided by 3, which is 1/3. So you see, these logarithm questions can just come in different form, and we have addressed 2 solid examples already. I'll take a third one very quickly. I hope you are writing. Now if you want to write, you can just pause the video, take a quick note, then you play on to continue. I'll take another example. Now very quickly, guys, let's say we have, for example, log 0.2 base 25. Well, again, I cannot express 0.2 in terms of 25, so I have to look for another way of addressing it. Let's say, for example, I made this equation to be equal to y. It means I want to change it to indices. Then 25 raised to the power y is equal to 0.2. I believe you know why we've written this already. Okay, so 0.2 is 1/5 in fraction. If you have problem changing decimal to fraction, please, you can tell me in the comment section so I can make a video on that. I'll show you how to change decimal to fraction. 0.2 is 2/10, and 2/10 is 1/5. Well, if you now bring in your indicial concepts, we can write 1/5 as 5 raised to the power minus 1, right? So this will be 5 raised to the power 2y is equal to 5 raised to the power minus 1. Okay, so 2y is equal to minus 1, then y is equal to minus 1 all over 2. You see, we have used this laws to address 3 different examples, meaning if you have the question coming in whatever form, you'll be able to address it very simple. I trust with these 3 examples you should be able to address quite a lot of questions when it comes to simplification. In my next class, I'll be looking at the other rules of logarithm. So if you're in Nigeria and you have a textbook SS3 maths, New General Mathematics, you can go to the exercise and try yourself out. I believe you have maybe like 1 to 20, 1 to 30, 1 to 10. Try yourself out using these laws on simple simplification. As soon as you are done, we will get another lecture going. Thank you very much, guys. I'm going to see you in my next class. Peace. Please don't forget to like and don't forget to subscribe. You can tell your friend also, they can learn from this place. Simple concept in mathematics. Thank you.